Okay, so anyone who's ever run a software project, you know what I'm talking about. You've been haunted by two simple but absolutely terrifying questions.
Yep, there they are, the classic, most dreaded questions in the business. Answering them can feel like you're just guessing, right? Trying to predict the future. And if you guess wrong, well, that's a one-way ticket to missed deadlines, blown budgets, and a whole lot of stress. But what if there was a way to move from a wild guess to a really educated estimate?
Well, this is where our hero of the day comes in. It's called the Constructive Cost Model, but pretty much everyone just calls it COCOMO. Think of it as a systematic way to finally tackle this estimation problem head on, bringing some real data and structure into the mix. So here's the key thing to get. COCOMO is not about pulling numbers out of thin air. It's a procedural model, which is just a fancy way of saying it follows a specific formula. It looks at how big your project is, usually measured in thousands of lines of code, or KLOC, and then uses historical data from similar projects to predict the effort you're going to need. It's all about turning, I think it'll take this long into, okay, the data suggests it's going to take this long. See the difference? And, this isn't some new, untested idea. The original COCOMO was developed by Barry Boehm way back in 1981 after he studied 63 real-world projects. And as software development changed, the model changed with it. COCOMO 2 was released in 2000, updated with data from over 160 projects to keep up with the times. So yeah, this thing has stood the test of time. Now, before we can actually use COCOMO, we need to get our heads around two core ideas. First, how it categorizes your project, and second, how much detail you actually need for your estimate. Let's break that down. Okay, think of these as the difficulty settings for your software project. First up, you've got organic projects. These are the smaller, pretty straightforward jobs, built by a small team that knows what they're doing. Then you have semi-detached, which is the middle ground. A medium-sized project, maybe a team with mixed experience levels. And finally, you have embedded. These are the big, complex beasts. We're talking flight control software, things with super tight constraints and strict rules. The model treats each of these very, very differently. Next, you get to pick your level of detail. We're going to focus on the first two. Basic COCOMO is your starting point. It's for a quick, rough estimate to just get you in the ballpark. It's kind of like a back-of-the-napkin sketch. But the real power, the thing we're building up to, is intermediate COCOMO. This is more like a detailed blueprint that actually accounts for all the unique things about your specific project. All right, now for the fun part. Let's get into the math and see how COCOMO actually turns the size of your project into a real, tangible number for how much effort it's going to take. So this is the engine of the basic model. E is for effort, which we measure in something called person months. KLOC is just the size of your project in thousands of lines of code. And those letters, A and B, those are special constants that change depending on that difficulty setting we just talked about, organic, semi-detached, or embedded. And before we go any further, let's make sure we're totally clear on this. A person month is just the amount of work one person can get done in 1 month. It's the standard unit of effort here. So if a project is, say, 24 person months, that could mean 2 people working for a full year, or maybe 4 people working for 6 months. It's a really simple way to wrap your head around the total amount of work. And here are those special constants, A and B. And this is where you can really see the logic of the model. Just look at how the numbers get bigger as the project type gets more complex. That's not random. That's the historical data kicking in. It knows that complex projects don't just take a little more effort, they often take exponentially more. That's why the B value is so important. Let's make this real with a quick example. Let's say we have a semi-detached project that we think will be about 30,000 lines of code, so 30 KLOC. We look at our table, grab the right numbers, A is 3.0 and B is 1.12. Then we just plug them into the formula. Effort equals 3.0 times 30 to the power of 1.12. You run the numbers, and you get about 135 person months. And just like that, you've got a data-driven starting point for your planning. But hold on. Any good project manager is thinking this right now. The basic model is cool, but what about the real world? What if my team is full of rockstar developers, or we're using brand new cutting-edge tools? Surely that has to count for something, right? Right, absolutely. And that is exactly why intermediate COCOMO exists. It adds this brilliant little thing called the effort adjustment factor, or EAF. Honestly, just think of it as a master control knob that lets you fine-tune that initial estimate based on the real DNA of your project and your team. This EAF number comes from looking at 15 different cost drivers that are grouped into these 4 buckets. Now, you don't need to memorize all 15, but you do need to appreciate what they cover. They ask about things like required reliability, team experience, and the tools you're using. Honestly, overlooking just one of these is how project timelines and budgets totally spiral out of control. And here's how it works. Each of those 15 drivers gets a rating, from very low to extra high. The model then assigns a specific multiplier for that rating. So for example, if your project requires high reliability, the model might assign it a multiplier of 1.15. That means just that one factor alone will push your final effort estimate up by 15%.
And this is the final piece of the puzzle. You take your original basic formula and you simply multiply the result by that EAF. It's that simple, but suddenly you have a much more refined, much more realistic estimate that actually accounts for the stuff that speeds projects up or slows them down in the real world.
So you might be wondering, why are we still talking about a model from 1981? I mean, in a world of agile and DevOps and crazy fast development cycles, why does COCOMO still matter? Because its greatest strength isn't just the final number. The real value of using COCOMO is that it forces you and your team to have a structured conversation. It makes you sit down and really think about things like complexity, team skill, and reliability. It forces you to replace vague assumptions with actual analysis. Of course, it's not a magic wand. The pros are obvious. It's systematic, it's data-driven, and it helps you spot the things that could really impact your project. But it has its limits. Its accuracy really depends on that initial guess for lines of code, which can be tough. It's also maybe not the best for really non-traditional projects, and it can't measure the unique chemistry of your specific team. It's a powerful tool for sure, but it's not a crystal ball. And that brings us to one last question to think about. The core idea behind COCOMO, systematically analyzing variables to estimate effort, that's timeless. But now, in an age of agile, DevOps, and even AI that's starting to write code for us, how do you think we're going to answer that age-old question in the future? How long will this take, and how much will it cost? The tools are definitely going to change, but that question is here to stay.